So before we move on into the depth of a data link layer, let us understand a history of how interconnection or internet came into existence. So basically, what I think is when computers were created, right, there came up a need which we had already discussed, that two computers wanted to talk to each other, right, or they wanted to share the information with each other. Now let's imagine that if more than two computers had to share information with each other, so let's imagine that we have two more computers also. So if they want to talk to each other, or if these four computers want to talk to each other, what I will have to do is I will have to connect these computers with each of them. So basically, they are connected together. So it's basically connection from one PC or one computer to another computer. So imagine that there are not four computers, there are more than four computers, like 10 computers or 50 computers there. So you will have to interconnect each of these computers. So that will then create more number of wires or cables being included in the network. Now to reduce this, what they came up is with a device, and that device was the first networking device, or I would say a device that can forward traffic from one point to the other point, and that device was called as a hub. So a hub can transfer one it can transfer a data from one of its entry point out of its all the exit points, meaning that if PC1 here or computer 1 here sends some information, what hubs does is hub will copy, will duplicate this data and send it out of all its other ports. This is how the hubs were created for. So if 2 sends some data, if number 2 PC sends some data, that information would then be copied and duplicated and sent out of all other interfaces. This was the work of a hub, copying and forwarding the same data out all its exiting ports or outgoing ports. Okay, so understand there are two types of ports. One is the entry port, that in networking we call it as the incoming port, and the other is the exit port or outgoing outgoing port. Okay, another name for ports in networking is called as interfaces. So incoming interface and outgoing interface. Okay, so once you start to learn computer networks, you will come across this word interface a lot. So now hubs were created. Now there was a need where I do not want the information to be sent to all the devices, meaning that if there is PC1, PC2, PC3, and PC4, so I only want the information to be sent from PC1 to PC4 only, and PC2 and PC3 should not receive this information. But if I use a hub here, what the hub will do is it will forward it to PC2 and PC3 also, which I do not want. So what can I do here? So I mean the engineers or the developers, they came up with another device which was called as a switch. So switch was the first intelligent device that can forward traffic, that can switch traffic from one port to other port based on few addresses. Okay, meaning that if PC1 wants to send some data to PC4, so PC1 will send it to the switch 1. What switch will do is it will transfer that information from PC1's this interface to PC4's this interface. Okay, and send it to PC4. So switching, the word switch was basically used to switch traffic from one port to other port. That is how the name came up, switch. So you are basically switching the traffic from the entry port to the exit port, or the incoming interface to the outgoing interface. So this was the work of switch. Now, so let me tell you in a brief of how switches usually work. So when switches usually work based on something called as MAC address. Okay, now this MAC address is basically just like an address that we have. Okay, all our houses have some address. Okay, so MAC address is very similar to that. So if someone is writing a letter to you, or if someone is sending some gift to you, that person will write your address on top of the courier or the gift, right? Now that address is unique. Okay, your house address is unique across the world, right? So someone who is sitting in America is sending some gift to your address. It will come to your address if the address is written correctly, right? Similarly, MAC addresses are addresses of all the networking devices. So your laptop, your mobile phone, your smart TVs, every networking device has a MAC address, and that MAC address is unique. Unique meaning, unique means that there are no other devices that will have the same MAC address. So PC1's MAC address will not be same as PC3's MAC address. Okay, it is just like our fingerprint. Our fingerprints are unique. Similarly, MAC addresses are unique. So on a layer 2 or a data link layer, the traffic or the information or data is forwarded or switched based on the MAC address. So if PC1 wants to send some data to PC4, what PC1 does is it will write its own MAC address. So PC1's MAC address, we call it as source MAC address, and PC1 will write the destination MAC address. The destination MAC address will be of PC4, and this will be of PC1. So when this packet arrives at the incoming interface of the switch reads the destination MAC address and finds out where does this PC4 connected to. It will then switch the traffic to the outgoing interface and send it out of that interface, and that packet or that information reaches the PC4. Okay, so this was how switch invented. Now as technologies developed, okay, so as you can see here in this diagram, okay, instead of 4 PCs, just imagine there are 100 PCs. Okay, or just imagine your college campus. So your college campus has different departments. It has a mechanical department, computer science department, civil engineering department, ECE department. Okay, there are so many other departments. It has HR department, it has some teachers department, it has administration department. There are so many departments inside. Now, all these departments, imagine that all these departments are one network, one small network. So in this diagram, imagine that this is ECE department, this is a civil department, this is, sorry, this is a mechanical department, and this is the IT department. Okay, so just imagine that there is a similar network. Okay, meaning that this is S. This, for example, this is my college, that was SKCT. Okay, now there is a similar college. Okay, there is a similar college somewhere in another city which also has ECE branch, civil branch, mechanical branch, and IT branch, right? And all their syllabus are same, right? So ECE wants to send some data to the ECE branch of this college. Let's name that college as ABC, right? So what will happen if ECE wants to send some data? What it can do is, or if the a user in the EC department, let's say there is this PC1, okay, in this EC department wants to talk to a PC in this EC department, what he can do is he can also send the data using the switching technology. So segregating these departments so that they talk only to their own smaller network. Okay, meaning that the IT department of my college can talk to the IT department of the other college. Similarly, civil can talk to civil, EC can talk to EC, mechanical can talk to mechanical. Such kind of configuration or such kind of departmental configuration or smaller similar network configuration, okay, that kind of configuration or that kind of feature is called as VLANs or virtual LANs. Okay, I'm pretty sure you would have heard this word called LAN. LAN is nothing but local area network. Okay, so in this diagram, if you see here, in this diagram, if you see here, they have configured PC1 and PC3 as one VLAN, PC2 and PC4 as another VLAN. For example, okay, so PC1 can talk only to PC3, PC2 can only talk to PC4. Okay, so such kind of configurations, such kind of information you would be learning in the data link layer. Okay, now there is another technology called as Ethernet, right? Ethernet. You would have heard this word. Okay, when a technician comes to your house and performs the Wi-Fi connectivity, he said the Ethernet, where is the Ethernet cable or Ethernet port, right? So basically, Ethernet technology works on the layer 2. Your wireless connection, that is your laptop to your Wi-Fi modem. That connectivity is also happening over a layer 2 connection. Okay, so we will also understand all these things deeper in the layer 2. Now, in the real time scenario, all your switches, okay, in a company, this is a server room of a company. Okay, so you can see here that this is one switch, This is one switch, another switch, another switch. All these are different switches. Okay, and just look at them. How are they connected? Through different wires. Okay, all these wires might be carrying some kind of information, right? So all these different wires may be part of a similar smaller network that is called as VLAN. Okay, so as an example, or just to make things clear that we read or I told earlier, this switch here, for example, if I configure it to be a part of VLAN 10, okay, and I configured this switch here to be a part of VLAN 10. So only this switch can talk to this switch. These two switches cannot talk to any other switch. So this kind of information, how to segregate traffics or data based on similar feature or similar smaller networks, is the study in data link layer. Now, here we talked about LAN, local area network, right? And how local area network is even more segregated into different smaller networks called as VLAN. So LAN basically is local and is in the smaller area. But how can two different users in different LAN location, for example, you are sitting at your home, you are part of some small VLAN. Your friend who is in some other city, or your friend who is in abroad, or your relatives who are in abroad, they will also be a part of their own VLAN. How is that VLAN member in America talking to a VLAN member in India? That is the work of layer 3. That is network layer. Okay, so if you can see here in this diagram, all these smaller boxes are LANs or local area network. Okay, so all these smaller boxes are LANs. If you see here, they are all connected through some wired technology or some technology, which we call it as WAN, wide area network. Wide area network. So connecting LANs, different LANs in different geographical location, we use WAN, wide area network. And wide area network has different technologies which will help different LAN to connect. Okay, few of those LAN or sorry, few of those WAN technologies are called as OSPF. These are in your syllabus too. OSPF, EIGRP, BGP, etc. Using these WAN technologies, you can connect multiple LAN networks. So, how can you understand this even better? Just imagine all these things as the map, your Google map. Okay, so I've taken here a Google map. Also, one more thing on layer 3, that is your network layer. Your layer 3 basically runs on something called as IP, Internet Protocol. Okay, now just imagine this map. Okay, from Coimbatore to Chennai, there are multiple roads that you can choose to go from Coimbatore to Chennai. Okay, so imagine your roads, as I mentioned here, imagine your roads as IP. Okay, imagine your roads as IP. That helps you from going from Coimbatore to Chennai. Okay. Now you're using train. Sorry, if you're using roads, of course you will not be using train. If you're using road, you can go from Coimbatore to Chennai via a bus, right? You can use your own car, you can use your taxis, you can use a bike, or if you have a lot of strength, you can use also a cycle to go from Coimbatore to Chennai, right? So all these vehicles, okay, consider all these vehicles as routing protocols. Now, what are routing protocols? Okay, as I mentioned earlier, OSPF, EIGRP, I'm sorry, it is not OSPE, it is OSPF. OSPF, EIGRP, BGP, they are all routing protocols. Now, what do routing protocols do? Routing protocols helps in finding the best path from Coimbatore to Chennai. That exactly what even your Google map does. If on a Google map you give your from location as Coimbatore and to location as Chennai, it gives you the best path to go from Coimbatore to Chennai. And that is basically marked in color blue, something like this, right? So calculating the best path to go from the source to the destination is the work of a routing protocol. Okay. Now, all these routing protocols work based on bandwidth. Bandwidth, you can compare the bandwidth as the number of lanes on a road. Okay. So, number of lanes, how can you imagine that? If the road is a one lane road, okay, if the road is a one lane road, okay, your movement will be slow, right? Because there will be incoming traffic and going traffic also, right? But if it's a two lane road, it's the road is a bit wide, your travel will be a bit fast, okay, but still you will not be able to drive faster, okay. If it's a four lane road, okay, meaning that there is two lane on left and two lane on right, correct? So if you are using a four lane road, you will be able to drive faster and reach from Coimbatore to Chennai even faster. If it's an eight lane road, meaning that there will be four lane on left and four lane on right. So your traveling time is also depending on the width of the road. Okay. Not only the width of the road, it also depends the kind of vehicle that you use. If you're going on an eight lane road and you're riding a bicycle, okay, there is no point because the speed of the bicycle depends on the strength that you have, right? If you are on the eight lane road, if you are driving a very fast car, for example, Mercedes, okay, Mercedes are very fast cars. If you're driving Mercedes on an eight lane road, you will reach even faster, right? So imagine your lanes as bandwidths or the uh, speed at which your traffic or you can drive the car, okay, and these locations, okay. Now here I will mark these locations, um, like here the E road, Salem, okay, Tiruvannamalai, and Kanchipuram. Though it's not going through Kanchipuram, but some junction here. Okay, all these cities that we go through are different points of intersection of multiple roads. Okay, in networking, these intersection of multiple wires or multiple connection is called as a device. that is called as a router. Okay, the work of a router is very similar to a switch, where it transfers your data from an entry point and send it out the exit point. Okay, so basically it is routing from incoming interface to the outgoing interface. Okay, that is the work of a router. So you will be learning similar kind of information in the layer 3 technologies. So in layer 3, you will be learning about routing protocols. All these routing protocols have different bandwidths, bandwidths meaning speed, how they transfer or how they take you from one point to the other point, how they choose the best path from one point to the other point, and how do different routers process these protocols. All these information you would be learning in the layer 3. Now, let's go to the next layer, that is your transport layer or layer 4. Now, imagine that in this layer 3, okay, imagine that this you are living in a very old era, or probably you are living in 1800s. Okay, when in India there were no phones, no telephones. Okay, there were no postal facilities, right? So if you are traveling from Coimbatore to Chennai, right, you will be using some road, you will be walking, probably, yes, of course, you will be walking from Coimbatore to Chennai, right? You will be using different, you will ask different people how to go to Chennai. They will direct you that you can go to Chennai using this road. And then you reach Salem, you will ask someone how to reach to Chennai. Similarly, at different junctions, you will ask how to reach Chennai, right? But your family is in Coimbatore. Okay, will they know have you reached Chennai safely or not? They cannot know until and unless you send them some information, right? Either you write them a letter, right, or you tie the letter at a pigeon's feet and send it to Coimbatore, right? So that's how your family living in Coimbatore will know that you have reached Chennai safely, right? So the guarantee of taking your information from one point to the other point and making it reach safely on the other side is the work of a transport layer. The IP layer or the layer 3 OSPF protocol or EIGRP protocol does not take that guarantee. They will take you through the best path, but they will not guarantee your reaching safely. That guarantee is taken by the transport protocol. Okay, so you can imagine your transport protocol in real life as your WhatsApp error messages. Okay, your WhatsApp error messages, if you see here, when you send a message to your friend, okay, it gives you a tick mark, right? So this tick mark is actually a notification or an acknowledgement, and acknowledgement that the message is sent. Okay, when you get a double tick, it means that the message is received by your friend, and when it turns blue, it means that your friend has read the message. So these are all a kind of information that you are actually receiving from the receiver, right? So it also tells you that your message has been successfully reached the other side. So this work is actually taken care by the transport layer. Okay, so you will also have seen such error messages that you have sent a message and the WhatsApp said not delivered. Okay, and here also it says not delivered. So what do? You click on the message and resend it. So this message is not delivered How does your phone know, or how does the WhatsApp know that your message did not reach? That information is given by the transport layer protocol. Okay, so you can see different screenshots of different error messages on the WhatsApp, right? All these information that you see is created by the help of transport layer. Now, in transport layer, there are two types of protocols that are majorly used: a TCP protocol, transport control protocol, and a UDP protocol, user datagram protocol. Okay, now I will give you again another real time scenario of where TCP and UDP are used. You are looking at my video, right? And you are looking at my video through some networking device, phone, right? And you are continuously receiving or you are continuously seeing this video, right? And there is no delay of messages. If you miss something, right? If you miss something, you can rewind this video and watch it again. All that is taken care by TCP. Okay, where does UDP come? All your live matches, live streaming, all of that is done using UDP. Meaning UDP basically does not guarantee, or meaning does not, I should not use the word guarantee, does not send an acknowledgement back to the sender. Okay, that is the work of you. That is the work of TCP. If it is acknowledging, that is the work of TCP. If it is not acknowledging, that is the work of UDP. So all your live stream, you watch a match on Hotstar, you watch a match on your cable TV, right? All those things, or all those things are done over UDP. Okay, you would have noticed some kind of a glitch, right? You would have noticed a glitch when you're watching a live stream. That glitch cannot be rewind because you're using a user datagram protocol, and user datagram protocol does not guarantee the uh, uh, reaching of your data perfectly. That is the work of TCP. So there are two types of protocol: TCP and UDP on a transport layer. You would be reading about these in the transport layer protocol. Now coming to the last layer, application layer. Okay, now this is where things get interesting. Look at this question here, what it says: what actually happens when you type an address in the browser? Now, if you type on your Google address bar google.com and press enter, what happens? You would have seen, if you would have noticed, under your browser, there will be some kind of information being written at the bottom of your screen, right? So something is happening at the background. And trust me, this is what happens in the background. So let me give you a simple example. When you do a google.com, okay, google.com is understood by us. Our computer does not understand google.com. It needs to convert this google.com into some kind of computer language or computer address. That computer address is called as an IP address. Okay, so it converts this google.com into IP address, and then when its IP address is found, it creates a TCP connection that we were understanding a few minutes before. It creates a TCP session or a TCP connection with this Google server's IP address, and then it starts to create the web pages. And when all these web pages, or when all the information in that particular web page is complete, then you see your Google page like this. So trust me, this is a very interesting part. But before you understand this, you have to understand a lot of basic things that actually happens under this layer. Okay. So as I had already told you, this is a TCP/IP layer protocol, and in the OSI layer model, this will be called as session layer, presentation layer, and application layer. Okay. So in computer networks, in your syllabus, you would be learning about all these things in detail. What is network layer, how do they pass information, in data link layer how is information passed, in transport layer how it helps in sending data end to end perfectly. All that information you would be learning in this subject. Now the main thing, if you learn this, what do you achieve? Well, I said computer networks is a study right now that in your BE syllabus, it's only wired technology that we talk about. Once you learn the wired technology, it is easier for you to learn wireless technology also. Okay. Now, you would have also heard security. Okay. These information, okay, if you're sending some information from PC1 to PC2, okay, or just imagine you're using WhatsApp, okay, have you ever seen a message written that your message is end to end encrypted, right? What is this? Meaning that no one else can read your message. This is a part of security. Okay, so once you learn how computer network works, you can also understand how security is implemented in computer networks. Using security, if you have interest in hacking, you can learn hacking also. Okay, if you have interest in hacking, you can learn cyber security, which is a very hot job right now. Okay, also, if you are good at coding, you can start to create automation tools. Okay, convert all these manual work that we learned right now in the past few minutes, you can convert those into automation. Okay, so once you learn computer networks, you have a huge career in front of you, different career, different aspects of career. Okay, one more thing that you can learn is cloud network, right? Cloud network. So all these things, once you understand computer network, once you understand how internet works, you have a huge area, you have an ocean in front of you, and you can find out which part of the ocean you want to be an expert in. Okay, but first you will always have to learn the basics. Without the basics, it's very difficult to understand security, it's difficult to understand wireless, it's difficult to become a cyber security. So welcome to this course, and let's understand the computer networks and its what, why, and how. Thank you and have a great day.